This is a short video about molarity and dilutions. So you've studied both of these before in general chemistry. They're both pretty simple mathematically to do. So molarity is one of the ways that chemists calculate or measure concentration. And molarity, symbolized usually by a capital M, is equal to the moles of solute divided by the liters of solution. So usually people say moles per liter. That's the molarity of a solution. So it's important to note we're always going to be in liters, not milliliters. So here's the first practice question. Calculate the molarity of a solution prepared by dissolving 11.5 grams of sodium hydroxide in enough water to make 1.5 liters of solution. So we already have our liters. We just need to convert our 11.5 grams of sodium hydroxide into moles. So we'll find the molar mass of NaOH, 23 plus 16 plus 1, so you get 40 grams is 1 mole of NaOH. So we have 0.288 moles of NaOH. So now our molarity is 0.288 moles divided by 1.50 liters. So this would be 0.192 capital M, and this is read as molar. So we have a 0.192 molar solution of NaOH. Easy. Here's another one. Calculate the molarity of a solution prepared by dissolving 1.56 grams of gaseous HCl in enough water to make 26.8 milliliters of solution. So two things to point out in this. It doesn't have to be a solid dissolved in a liquid. This is a gas dissolved in a liquid. Still creates a solution. And in this one, we want to be careful with our milliliters. So, same as before, let's convert 1.56 grams of HCl to moles. So 1 mole of HCl is 36.46 grams. And that's going to give us 4.28 times 10 to the minus 2 moles, or 0.0428, works too, moles of HCl. Let's convert our 26.8 milliliters into liters. Just a metric refresher here. There are 1,000 milliliters in 1 liter. So we're going to divide 26.8 by 1,000 to get 2.68 times 10 to the minus 2 liters, or 0.0268. That's fine too. So the molarity is 4.28 times 10 to the minus second moles divided by 2.68 times 10 to the minus second liters. And that's going to give us 1.60 molar HCl. So this would be if you're creating a solution made from a gas or a solid, something where you don't already have a solution that's made. Sometimes you make a solution from a solution that you already have or a stock solution. So stock solutions are concentrated So it's a concentrated solution that's used to make other solution. So you simply add water to the stock solution to dilute that solution to make the concentration lower or to decrease the molarity. So there's a simple formula for doing dilution mathematics, and that is M1 V1 equals M2 V2. So the M's are molarities, and the V's are volumes. Molarity is always recorded in moles per liter, but you can see mathematically that your volume can be in liters or milliliters as long as V1 and V2 are in the same units. Let's check out an example. What volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of 0.10 molar sulfuric acid? So we're trying to make this. This is a set. Okay? This is our second volume and our second molarity. Okay? The one we want to make 1.5 liters of 0.1 molar. That's a set. So then this molarity, the 16 molar, that's our stock solution. That's what we're starting with. That's our M1. So we want to know what volume of M1 are we going to need to make this second solution. So let's plug that into our M1V1. Let's use a different color. So M1 is 16 molar, V1, and that's equal to M2. And V2 right now is in liters. You can leave it in liters. You can convert it to milliliters if you want. It doesn't matter. Let's just leave it in liters. Okay. So we're going to solve for V1 by dividing everything by 16 molar. And you can see here that the molarities cancel and you're left with liters. So if we'd had milliliters in there, it wouldn't have been a big deal. We just would have gotten an answer in milliliters. So when you do this math, you get 9.4 times 10 to the negative third liters. Oh, maybe we should have put it into milliliters. 1 liter is 1,000 milliliters. So we could also say 9.4 milliliters of 16 molar sulfuric. So we would take 9.4 milliliters of 16 molar sulfuric acid and put that in a volumetric flask, and then we would fill the flask up to the 1.5 liter mark to create our new solution.